In 41 through 46, we are asked to graph each of the following functions, finding their domain and the new origin point. So in a square root function, whatever sits under the square root cannot be negative, so it must be greater than or equal to 0. Solving that inequality, the domain is x is greater than or equal to -6. If we recognize that when x is -6, it makes that radicand equal to 0, that's going to help us find our new origin point. The x value is -6, and the y value is 2. All right, from there, we can just graph the parent function, because I don't see any other operations other than addition and subtraction and the parent function. So using our parent function, for the square root of x, we can start with 0, 1, 4, and 9 as x values, and their square roots as the y values. And then just graph those points, but from the new origin. So from the point -6, 2, I'm going to graph 0, 0 on the new origin, 1, 1, 1 to the right and 1 up from the new origin, and then 4, 2, 4 to the right and 2 up from the new origin, and then finally 9 to the right of the new origin and 3 up, and that will provide us with a nice smooth curve of that square root function endpoint there at -6, 2, the new origin. In 42, this is a similar type of a question because it's a cube root function, but the only other operations other than cube root are subtraction and addition. That means it's just a translated function, so we can just translate over the new origin and graph the parent function. So the domain here, however, is all real numbers because a cube root of any number, any real number, is another real number. That is to say that we can take the cube root of a negative number. So there are no restrictions on the domain here. The new origin is 1, 3. The x value can be found by finding the value of x that makes the inside of the function, which is x minus 1, equal to 0, and 1 minus 1 is equal to 0. All right, from here, we can graph the parent function from that new origin, and so x and the cube root of x. Now remember, we can take the cube root of negative numbers, so let's list our perfect cubes here. -8, -1, 0, 1, and 8, and their cube roots are -2, -1, 0, 1, and 2. So from the new origin, 1, 3, I'm going to graph each of those 5 points. First point, 8 to the left and 2 down from that new origin. So that would be right there. And then 1 to the left and 1 down from that new origin. 0, 0 is on the new origin. And then 1, 1 would indicate 1 to the right and 1 up from the new origin. And then finally, 8 to the right and 2 up from that new origin. Connecting the dots, we have this nice smooth graph that looks a lot like that cubic function from earlier in the year. In 43, let's graph this square root function. Our domain consideration is that the inside of that square root has to be greater than or equal to 0. Now, if we solve for x by dividing by -1, that means that our x values have to be less than or equal to 0. Our new origin is at the point 0, 0, because there is no addition and subtraction indicated in this, so there's no translation of the graph. For purposes of a graph where you have a negative x inside of the radical, here's what I'd suggest. Just use a straight table of values. Okay, so I'm going to use my domain here to indicate that x's are going to be less than or equal to 0. So that means I'm going to start with 0, but I'm going to indicate less than. So -1, -4, -9. Okay, our perfect squares, but they're opposites. And then we're going to take the square root of the opposite of x, and then finally multiply that by 3. So we can sort of do this in stages. The opposite of 0 is 0, its square root is 0. The opposite of -1 is 1, its square root is 1, and so on. That's going to give us 2 and 3. Multiply each of those by 3, and now we have the y values. So I'm just going to graph 0, 0. There's no translation, remember. -1, 3, -4, 6, and negative 9, 9. And there's the graph of our function. In 44, we have another cube root function. Remember, the domain of a cube root function is all real numbers. Our new origin is negative 1, negative 5. The x value is the value of x that makes the inside of that cube root function equal to 0. All right, so here's what's going to go on from here. I'm going to just imagine that I take all of the addition and subtraction out. And so the only other operation is that times negative 2 outside the radical. So when I create my table of values, I'm going to use the cube root function here, but then I'm going to multiply each of those values of y by negative 2 to get my final y values. So x would be negative 8, negative 1, 0, 1, and 8, taking their cube roots, negative 2, negative 1, 0, 1, and 2, and multiplying each by negative 2. That gives us positive 4, 2, 0, negative 2, and negative 4. So the first and last rows here, or first and last columns, I should say, are going to be graphed from the new origin. So I'm going to graph the new origin, negative 1, negative 5, and then graph those points from there. So 8 to the left and 4 up from that point, 1 to the left and 2 up from that point, 0, 0's on that point, 1 to the right and 2 down, and finally 8 to the right of that point and 4 down from that new origin. Remember, all of those points that we're graphing are relative to the new origin. All right, in 45, we have another square root function. So that means whatever the contents of the radical are, those have to be greater than or equal to 0. Solving for x, the domain is x is greater than or equal to negative 4. So our new origin is negative 4, 0. We don't see any addition or subtraction on the outside of the radical. So I am going to graph from that new origin, and I'm going to take all of the addition and subtraction out of it. So our x values, 0, 1, 4, and 9 for square roots, take their square roots, 0, 1, 2, and 3, multiply each by negative 2, and now we have 0, 0, but remember that's relative to the new origin, right? So negative 4, 0 is the new origin, 0, 0's on that point, 1, negative 2, that's 1 to the right and 2 down from that point. 4, negative 4, that's 4 to the right and 4 down from that point. And then 9, negative 6, that's 9 to the right and 6 down from that point. And that gives us that nice half of a parabola shape. In number 46, we have a cube root function. Domain's all real numbers. And our new origin is the point 0, 2. There's no addition or subtraction inside the radical, but there is a plus 2 outside. So from that new origin, we can graph using our x values for the cube root function, and then take their cube roots, and there's one operation left to account for, and that is times negative 1. So I'm going to use my x values for cube rooting, and take their cube roots, and then multiply each by negative 1. And then we're going to graph those first and last columns as our x and y pairs, but from the point 0, 2, which is our new origin. So from the new origin, 8 to the left and 2 up. And then from the new origin, 1 to the left and 1 up. 0, 0 is the new origin. And then 1, negative 1 means 1 to the right and 1 down. 8, negative 2 means 8 to the right and 2 down from that new origin. There's that nice cube root shape for that graph.